Here we're going to look at an example of a definite integral and then an application of definite integrals. Let's look at the example first. We're asked to evaluate the integral from 0 to pi over 6 of sine 3x dx. Well, we can do this using the method of integration by substitution, which we discussed in a previous video. If we let u equal 3x, then du by dx is equal to 3, so dx is equal to 1/3 times du. So the integral from 0 to pi over 6 sine 3x dx equals the integral of sine u times 1/3 du. But now we have to be careful about our limits. The limits we have are for x. We need to use these values to find limits for u. U is equal to 3x, so 3 times 0 is 0, and 3 times pi over 6 is pi over 2. So we have 1/3 the integral from 0 to pi over 2 of sine u du, which is 1/3 times minus cos u, evaluated between 0 and pi over 2, which is just 1/3 times minus cos pi over 2 minus cos 0, which is 1/3 times 0 plus 1, which is just 1/3. So when we use substitution to compute a definite integral, we have to make sure we also substitute the limits. Let's move on to the second example. We're asked to find the area of the finite region bounded by the curves y equals x squared and y equals 2x. In problems like this, the first thing we should do is draw a diagram to show these curves. Here's the line y equals 2x, and here's the curve y equals x squared. We're interested in this area here. That's the finite area in between the curves. The first thing to do is to find the 2 points where these curves intersect, since then we'll know at which x points this region starts and ends. So we must set 2x equal to x squared and solve. Rearranging gives x squared minus 2x equals 0, giving x times x minus 2 equals 0. So the solutions are x equals 0 and x equals 2. So that's these 2 points here and here. You'll also notice that the line y equals 2x is always above the curve y equals x squared between 0 and 2. So if we integrate 2x from 0 to 2, we'll get this whole area here, call it area A. If we integrate x squared between 0 and 2, we'll get this area here, call it area B. Hence, if we subtract the second integral from the first, we'll have a minus b, which is equal to the area here that we are looking for. But since integration is linear, and the limits are the same in both integrals, we can rewrite this integral as the integral from 0 to 2 of 2x minus x squared dx. So let's now evaluate this integral. We have 2 times x squared over 2 minus x cubed over 3 between 0 and 2. Here we have a factor of 2 cancelling, to give just x squared minus x cubed over 3 between 0 and 2, which is 2 times 2 minus 2 cubed over 3, subtract 0 minus 0 over 3, which is just 0. So we end up with 4 minus 8/3, which is equal to 4/3. So the area of the shaded region is 4/3.